Hello everybody, welcome to my channel Physics Infinity. We carry on the discussion on problems of ray optics. I take on another interesting problem on ray optics where you will understand once again the utility of the RIP-VIN convention, which of course I am very much fond of, and I've always been stressing that to solve the tricky and interesting problems of ray optics, it is better, far better, to use the RIP-VIN convention than the usual Cartesian sign convention that you have been used to in your school level work. Well, I take on a problem where there will be an application of the lens maker's formula, the famous lens maker's formula, its application, but in a different novel manner via this problem. Well, the problem is this, that there is a Plano convex glass lens, no, it's not a glass lens, Plano convex lens of certain material having refractive index, say N. I should not actually use glass because that gives you the clue that no, it's not glass, but it's some medium. So medium, I can take this as a medium to, okay. So this is the material, and when it is placed on a horizontal table, then the bottommost point when seen from above, the bottommost point when seen from normally above in air, the bottommost point appears to be 3 centimeter. Well, you can call that as the apparent depth, which you have learned in your junior class, and the actual depth from top surface to the bottom, that is 4 centimeter. So I can take 4 centimeter as real depth and 3 centimeter as the apparent depth, and that will give me straight away the refractive index for the material of the lens as m with respect to A as 4/3, the real depth upon apparent depth. Fine. Then the problem says that if you invert the lens, and now the flat surface is on the horizontal table, and well, the P, if you take as the pole, and if the rays go from the bottom point above and enter from the material into air, then, well, it appears to be from above, the distance to be, the image appears to be 25/8 centimeter as seen from above. I'm not drawing the ray diagram. Well, that's quite obvious. So, well, we have been asked to calculate the focal length of this lens, the focal length of this Plano convex lens. Okay, let's get going. So here we are. From the first information, real depth upon apparent depth, easily I get the refractive index for the material of the lens with respect to air, real depth upon apparent depth, that's 4/3. And then I take on the figure, so this is from figure 1, then I take on the figure 2. And for figure 2, I am using the condition that the rays are going from material to air, So P is the pole. Well, I can take this O as the object, and this object, when seen from above through the lens, has a virtual image. Now mark my word, I have emphasized on the word virtual, because in the sign convention I am going to use RIP-VIN. Virtual is negative, real is positive. RIP-VIN, real is positive and virtual is negative. So be careful. So I am emphasizing on that. And accordingly, I am going to put plus or minus in the equation that I am going to use. So here you are. So its virtual image is seen to be 25/8 centimeter as given in the problem. Fine. I use this refraction formula, refraction through P for the ray going from material of the lens to air. So I have Nm upon U plus Na upon V. This is the formula according to the RIP-VIN convention. I told you in the RIP-VIN convention there is no minus in the algebraic formula. Then the difference of, well, this is Nm difference Na and divided by R. I put down that. So 4/3 upon plus 4. The object is real. The image is virtual. So 4/3 upon plus 4 plus Na 1.0, refractive index for air, and virtual image, so minus 25.8, minus 25.8. The difference of the two, 4 by 3, difference 1 is 1 by 3 divided by R. I get from here R as 25 centimeter. I put this in the expression, I get R, and if R is coming out to be plus, that also says that this one is a convex surface. This is a convex surface. I write here converging surface. Well, once I have done that, now I use the lens maker formula, because I have to find the focal length. So for the lens maker formula, 1 by f is the difference of the refractive indices. So 4 by 3 difference 1 divided by the medium in which the lens is kept. Well, that is 1, it's kept in air, and plano convex R1, well, plane surface has radius curvature infinite, and R I have found to be as 25 from the above discussion. I just put that, I get f equal to plus 75 centimeter. So here you have understood the application of the RIP-VIN convention to solving this particular interesting and typical problem. I hope you've enjoyed the problem. I've also enjoyed teaching you this. Thank you very much. Do subscribe my channel.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.